Okay, in this question, we're looking at percent yield. We're not doing any sort of gram calculation. We're going to keep it in moles. We're given the moles of both reactants, 2.2 moles of xenon, 2 moles of fluoride. And then when we carry out the reaction, we see that we have 1/4 of a mole of our product. So what is the percent yield? So first thing we have to do with any sort of limiting reactant is figure out how many moles of product each reactant would provide. In this case, we don't have to go to grams at the end. We're just going to stay in moles. So let's look at both of these. So 2.2 moles of xenon. And then we're going to get out of moles of xenon and into moles. Into our xenon tetrafluoride. And we see that is a 1-to-1 ratio. So we have 2.2 moles of our product. With fluoride, we have 2.0 moles. And we're going to get out of moles to our moles of xenon tetrafluoride, and we have a 2-to-1 ratio. So we're multiplying by half, so we only have 1 mole of our product. So this is our limiting reactant here. So that is our theoretical yield is 1 mole, but what we found is that we had only produced 0.25 moles out of a theoretical 1 mole. Multiply that by 100 and we get 25%. Let's try that. There we go. So yield can be done in grams. So it's possible maybe you would find that the number of moles of product from both reactants and then convert the lower one, the limiting one, to grams of the product. And then if you were given grams of an actual yield, you'd put that over the theoretical and solve for percent yield the same way. In this case, we just had moles. But you can solve for theoretical with either moles or grams.